The signal flow graph shown in figure has how many number of forward paths and loops here. Okay, so first we will see what is a basic definition of a forward path. What is a forward path? A forward path is a path in the signal flow graph that connects the input node to the output node without touching any single node or path more than once. So here the important sentence is without touching any single node or path more than once. Okay, so let me give names and numbering to the paths here. So here I have, let's say, 1 here, and 2, 3, 4, 5, 6, 7, 8. Now how many number of forward paths here we have? So let's say first of all F1 is a forward path 1. So forward path 1 will have 1, 2, 3 directly. So it will have 1, 2, 3. So next forward path 2. So let's see here. So 1, and we can have 4 and 5 and 3. So 1, 4, 5, 3. Is it another forward path here? No, in this way we can't go, in this way we can go, in this way we can go. So they are opposite directions now, so we cannot go. Next is we need to find how many number of loops. So with the basic definition of a loop, it is a structure in a signal flow graph that leads to back itself. That means it leads to back itself. That means it has to start at the same point and it has to end at the same point only. So in this case, how many number of loops we have here? So first say L1 loop. So loop we have first one is 4, 6 here. So in this way we have one loop. So 4, 6. Similarly L2 is nothing but we have 2 and 8 and 6. So 2, 8, 6. Next loop 3 we have 2, 7 here. So 2, 7. And similarly L4, 4 and 5 and 7 like this. So 4, 5, 7. Next L5 we have 5 and 8 here. Okay, and we don't have extra other loops. So here we have totally these are 2 forward paths, and here we have 5 loops. So 5 loops, 2 forward paths. The option is A. Next we have second question. Which of the following is true for Fourier coefficients of an odd formulae? And the given options are here. Now the basic formula for the Fourier series expansion is f of x is equal to a0 by 2 plus sigma I is equal to 1 to n an into cos nx plus bn into sin nx. So this is a basic formula, and where here a0 is equal to 1 by pi integration from minus pi to pi into f of x into dx, and similarly an is equal to 1 by pi integration from minus pi to pi f of x into cos nx into dx, and similarly bn is equal to 1 by pi integration from minus pi to pi f of x into sin nx into dx. Now they asked the formula for odd function. What is the meaning of the odd function here? So what is the meaning of odd function here? So odd means if f of minus x is equal to minus of f of x, then we can call this function as an odd function. In this type of functions we have only sine terms, that means cos terms are absent. Similarly, if they ask for even function, so even means f of minus x is equal to f of x. In this term we will have only cos terms. So in the given question they asked what is the formula coefficients of an odd formulae. So odd formula means only we have sine terms, that means sine terms means this one, and this one is going to be 0, and this one is going to be 0, and this is not equal to 0 here. Okay, and the option that we are having here is a0 is 0, an is 0, and bn is not equal to 0. So this is the correct option. Here we may ask a question, sir, why not a0? Why a0 is 0? A0 is nothing but it's an average value. For a sinusoidal waveform, the average value is 0. And the next question, which of the following parts of h parameter has same dimensions? H parameters means it's a two-port network which will have two terminals at the input side and two terminals at the output side. So let's say H parameters. Okay, and the basic equation belongs to this two-port network is V1 is equal to H11 V2 plus H12 into I1, and similarly we have I2 is equal to H21 into V2 plus H22 into I1. So I1 is the input side current, and V1 here, and V2 here, and here we have I2. Now what is the H11? So H11 is equal to, so V1 by V2 at I1 made 0. It is having no units. Next, what is H12? H12 is nothing but this is equal to V1 by I1, V1 by I1 when V2 is 0, that is V2 made is short circuited here. So this is having a units of ohms. And similarly H21 is equal to I2 by V2 when I1 is made 0. It is having a units of mho. And finally H22 is equal to I2 divided by I1 when V2 is made short circuit. It is having no units. In the given question, which of the following parts of pairs of H parameter has same dimensions? So these two are different dimensions, and H11 and H22 having no units. So same dimensions means C is the answer here. So here in the next question, for the single element two-port network shown in figure, Y11 is. So here it's a two-port network. The basic formula for Y parameters is I1 is equal to, so Y11 into V1 plus Y12 into V2, and similarly I2 is equal to y21 into v1 plus y22 into v2. In the given question, they ask you to find what is the y11. So y11 is nothing but is equal to I1 by v1 when v2 is made short circuit. So here from the figure, what you can observe is here we have v1 as an input side voltage and v2 as the output side voltage. If v2 is 0 means short circuit. So short circuit means if you shorted here, then what about v1? So v1 also 0, and admittance y11 is going to be infinity. Okay, so it is not possible, not existent at here. Okay, and the next question, the reduced incident matrix of the graph shown in figure is of order. Normally the order of incidence matrix, the order of incident matrix is number of nodes into peer branches. Okay, so we'll note the branches here. So first I will take number of nodes. Let me this as a node A, node B, node C and node D. Let me give a name let me give names for branches 1, 2, 3, 4, 5 and 6 here. So the order of the matrix is nothing but number of nodes are 4 into 6. Okay, now here the important caution is we have to choose any one node as reference node, so that I will choose this D node as a reference node. Now the incident matrix has changed its order to n-1 into B. That implies it is having 3 cross 6 is the matrix. If you draw the matrix here, we'll have nodes 1, 2, 3 and elements here 1, 2, 3, 4, 5, 6. The order of the matrix is 3 cross 6 and the option is C is the correct option. Next question, which of the following function is not an even function? Here the condition to be satisfied for even function is, condition is if function f of x is equal to f of minus x. That means f of minus x and f of x both are same, means we can call that one as a even function. So let's check with the option A. Okay, so f of t is equal to, what is that, f of x is equal to t square. F of minus t also will get t square only. So f of t here and f of minus t here. Similarly, second case, f of t is equal to, so t power 4. F of minus t is equal to minus t power 4 only. So C option, f of t is equal to sine t. F of minus t is equal to minus sine t. So this is the correct option. And let's check with the D also. F of t is equal to cos t. F of minus t is equal to cos t only. So in the given options, C is the not an even function. Okay, The same question if you ask other means, by which of the following function is an odd function? So it can be asked as odd. What is the odd function in the given options? Okay. And the seventh question here, the analog to digital converter having highest speed conversion is dash. Normally the conversion speed in ascending order I will write here. Conversion speed in ascending order. The first one here we have is dual slope or integrating type ADC. Dual slope or integrating type analog to digital converter, which is lowest conversion speed among all. And next one, second one, counter type. And third one we have successive approximation ADC, and the fourth one is flash ADC or parallel ADC. So in the given option, so this one is having highest conversion speed. So the flash type or parallel type analog to digital converter is having the fast conversion speed or highest conversion speed among all the E to D conversion speed. The next question, identify the 1-bit comparator circuit. So for this bit the solution is normally XOR and XNOR is used as 1-bit comparator. Okay, so directly we can say the option is A is here. Okay, we can cross check it. Suppose let's say here we have inputs A and B. XOR means exclusive OR we have here. Okay, now we will write the truth table for this. Truth table A, B, A exclusive OR B is nothing but A exclusive OR B plus A B bar. So 0 0 0 1 1 0 1 1 here, and here you have 0 1 1 0. If you observe here, so 0 0 means output is 0. So if the both are same means you are getting 0. So both are same means here 1 1 also 0. So it acts as a unequal comparator. Unequal comparator here. So 0 0 means 0, 0 1 means 1, 1 0 means 1, 1 1 means 0. Next question, for the T flip-flop Qn plus, that is the next state, is given by, okay, normally it is Qn plus 1 is given by T exclusive OR Qn here. This is nothing but T bar Qn plus Qn bar into T. So in the given option the A is the right answer. Suppose if they ask for S flip-flop, SR flip-flop, so if they are asked for SR flip-flop, so Qn plus 1 is equal to S plus R bar Qn. Similarly for JK flip-flop, Qn plus 1 is equal to, so J Qn bar plus K bar Qn. And for D flip-flop, so Qn plus 1 only. Okay, and next question. And the next question here, for the timer circuit shown, find the output frequency. Here we need to find what is the output frequency F0 here. Okay, so here we have 555 timer, and observe here that the pin number pin 6 and 2 are short circuited, means they act as free running oscillator. Free running oscillators. Next, here the pin number 7 is nothing but a discharge pin. Here when we apply VCC supply here, that is VCC apply here, the capacitor is going to charge through the resistance this one and this one. So let me name it as, so RA is a resistance and RB is a resistance. These two resistances are called as charging resistances. Right. So when the VCC on, when VCC given, C capacitor here, the capacitor C charges through RA and RB. Now this time the charging time, so charging time is equal to 0.693 into RA plus RB into C. So RA plus RB into C. Similarly, when the capacitor discharges through 7th pin, there is nothing but discharge pin. So when T discharging is equal to 0.693, so only RB is present now, so RB into C. Now the total time taken for charging and discharging, so total time is equal to 0.693 into this one, so RA plus 2RB into C. So this is 2 added together means total time. Now frequency F0 is equal to 1 divided by 0.693 into RA plus 2RB into C. This is equal to 1 divided by, how much we have, 0.693 into RA is nothing but 7.2 into 10 power 3 plus here we have 3.6, so 2 into 3.6 into 10 power 3 into 0.1 into 10 power minus 6, and if you solve this we get the answer as 1 kilohertz, and the option here we have is B is the right answer. Okay, thank you friends, thanks for watching my videos. If you like this video, please comment and subscribe, and we will discuss the remaining questions from the APSPDCL 2014 AE solutions in the next coming sessions. Thank you. Here the core of two-winding transformer is subjected to magnetic flux variation shown below. In the given problem we are having A, B input, that is the primary side of a transformer, and CD as a secondary side of a transformer. N1 is 200, N2 is 500. The flux variation is given here, so it is having three unequal intervals. From 0 to 0.06 is one interval, from 0.06 to 0.01 is a second interval, and from 0.1 to 0.12 as a three intervals. So here what we need to find is EMF. What is the relationship between EMF and flux? It is nothing but simply E2 is equal to N2 into d phi 2 divided by dt. Okay, so first we will see the interval between 0 less than t less than 0.06. we will see this, and after that we will go for the second interval. So during this interval what is happening here is we will write the equation, slope equation. So how we'll write? So y minus y2 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. So during this period we will write what is a y2. So here we have xy coordinates, so this is y2 and this is x2, and x1 y1 as origin here. So y minus y2 is nothing but, so y minus y2 is 0.009 is equal to y2 minus y1, that is 0.009 minus 0 divided by x2 is 0.06 minus 0 into x minus x1 is 0.06, and we substitute this y as the flux of phi and x as time t. So phi is equal to, finally substituting equation, so phi is equal to, we will get 0.15 t plus 0.009 here. This is a phi 2. Now if we substitute, E2 is equal to, N2 is how much? 500. So 500 into d by dt of 0.15 t plus 0.009. So this is a constant, so differentiation of a constant is 0, and d by dt of dt, so t is going to be 1. So 0.15 into 5, 75 volts. And second case we'll see the interval between 0 or not 0, the interval is this interval, that is 0.06 less than t less than 0.1. During this interval flux is constant, so E2 is N2 into d by dt of constant, so this is going to be constant now, 0, so E2 is 0 volts here. Now we'll see the third interval. So next, the third interval is in between 0.1 less than t less than 0.12. In this case we will write the slope equation directly. I will write here, so phi 2 minus 0.009 is equal to minus 0.009 divided by 0.02 into t minus 0.12. So from this, finally what you got is phi 2 is equal to minus 0.9 divided by 2 into t plus 0.12 into 0.12 into 0.9 divided by 2. This is the equation. So finally next we will write the equation E2 as, so E2 is equal to, N2 is 500 into d by dt of phi 2, which is equal to, so 500, so differentiation of a constant is 0, so this term is going to be 0 here, into d by dt of, I'll write here 0.45 into t plus everything, alright, it's a 0.12 into 0.12 into 0.9 divided by 2. So differentiation of this one is going to be 0 here. Now final what you will have is equal to 500 into minus 0.45 is nothing but minus 225 volts. So three intervals, during the three intervals, first interval we have 75 volts, so let's see which option is chosen. So first one is 75 volts matching, but second interval 0 is matching. Third interval we have 225, so but here it minus 90, so C is the answer for this question. Now the next question is here, the following characteristics of three-phase induction motor refers to a speed control method. identify the correct option. In that one, V by F control, and variable V and F is F rated, variable F and V is V rated, and cascaded connection. Okay, and here we will see the basic formula. So T is proportional to 180 by 2 pi ns into slip into R2 into E2 square divided by R2 square plus S into X2 whole square. Generally, from this formula, what you can write is torque is proportional to 1 by F. Okay, so specifically if you write means starting torque is proportional to 1 by F cubed, and T maximum is proportional to 1 by F square, and slip S is equal to 1 by F. Alright, so as slip increases means frequency decreases, T max increases as well as T starting torque increases. When the slip increases means slip is 0 here, so slip is increasing in this direction, so slip increases in this direction. So as the slip increases, frequency decreases, maximum torque increases here, 1, 2, 3 and 4 here. So these are the variations in flux. So this is happens only in case of variable frequency, and V is a V rated condition only. The next question here, 10 thyristors are used in a string to withstand a DC voltage of 15 kV. The worst case steady state voltage across the thyristor is 1800 volts. The derating factor is, the formula for the derating factor is derating factor is equal to 1 minus string efficiency. What is the string efficiency? So string efficiency is equal to, series connection is total voltage across the string divided by number of SCRs in the string into maximum voltage across the one SCR. So efficiency, string efficiency is equal to, the total voltage is 15,000 divided by how many number of SCRs? 10 SCRs into each voltage is 1800. So 0, 0, 3 zeros cancel, 3 0 is nothing but 15 by 18. Now the derating factor is equal to 1 minus 15 by 18. You got 3 divided by 18 divided by 1 by 6. Now in terms of percentage, so derating factor, percent derating factor is equal to 100 divided by 6, which is equal to 16.67 percentage. But in the given option, the approximate answer will be B only. Next question, in multiple pulse equal pulse with modulation with the frequency, carrier frequency 15 kHz and the required output frequency 500 Hz, the number of pulses per half cycle in inverter output is. Here we have a inverter output. Inverter output is generally, it's a square wave like this. So this wave is also known as, it's a reference waveform, or also known as low frequency waveform or square waveform here. Now next, the carrier frequency is nothing but it's a triangular like this. So like this we will have carrier frequency. So this frequency is known as carrier or high frequency. Carrier or high frequency. Now the formula for the number of pulses per half cycle is number of pulses for half cycle is equal to width of an half of reference cycle divided by width of an one cycle of carrier waveform. So this is equal to, what is the width here? So here width of this waveform divided by width here. So width of an half of the reference cycle is nothing but time period. So time period is half for half cycle means actually, so time is proportional to frequency, inversely proportional to frequency. So 1 by, what is the frequency of this square waveform output is 500 Hz, but it is a half period now, so we'll multiply with 2 here. So into width of n, so only 1 by, so width of n one cycle of carrier waveform, so 1 divided by width of n one cycle of carrier. What is the frequency here? 15 kHz. I will write, so 15 into 10 power 3. This is equal to, so 15 into 10 power 3 divided by, so 1000. It is equal to 15. Hence the number of pulses per half cycle in the inverter is 15. The next question here, the effective input resistance seen by the source in the given circuit is. So whenever the question is asked effective resistance means it is always the resistance between the source. Okay, so effective resistance is with respect to voltage and current of source. So REFF, effective resistance, is equal to source voltage divided by source current. So this is chopper circuit, so Vs divided by I is nothing but alpha into Vs divided by R. So Vs both are same, so finally we'll have R by alpha. So this is equal to R is 10 divided by alpha. So here alpha in the given problem, so alpha is given as T on by T, which is nothing but 0.2. So this is given in problem. So 10 divided by 0.2, that's nothing but 50 ohms is the answer.